Welcome to Lesson 1 of States of Matter. If you have not done so, please pause the video and title ISN page 81 with States of Matter. Today is Monday, November 26th. As you go through this video, remember to write down any underlined information you see. While you're taking notes, I want you to create notes that work for you and that you're going to be able to use to study with later. So underline important terms, put spacing or indent the supporting details from the main idea. Make it so that you can tell what categories this page of note is about and what details you need to know about each of those categories. Pause the information or pause the video when you need to write down information, and make sure that you rewind the video if you were unsure of something that was said or if you need to hear it again. So let's get started with the notes. There are three states of matter: solids, liquids, gases. The state of a substance at room temperature determines whether or not it gets called a solid, liquid, or gas. For instance, we are solids at room temperature, so humans are solids. Your soda is a liquid at room temperature, so it's a liquid. And gases, like the air we breathe, they are a gaseous state at room temperature, so that's why we call them gases. The differences in the states of matter are due to a couple of things: their density, their molecular energy, which is how fast the particles in them are moving, and their shape and volume at room temperature. So let's get started with solids. And remember, you only need to write down the underlined information in your notes. So solids, they have a fixed shape and fixed volume. That means their shape and volume never change. It's always the same. They also have a high density. And by high density, we mean there's a lot of matter packed into one little space. So anything that fits the description of having a fixed shape and fixed volume is a solid. So you're a solid: the desk, your pencil, the paper, you're writing on the shirt you have on, your couch at home, the floor, the trees, the grass, vehicles, all of those things are solids. Solids also have the lowest energy, meaning their molecules, which you see here, are packed really tightly together, and there's a really strong attraction, like a bond, between each of those molecules. So even though you can't see or feel the molecules vibrating in a solid, they do. The molecules inside you are vibrating just right there in their little space. The molecules in the desk are vibrating. The molecules in your pencil are vibrating. They're just so small, and it's such a tiny vibration that we can't feel it. Second state of matter is liquids. So we know that liquids can change shape, but they cannot change their volume. Liquids have a lower density than solid, but a higher density than gases. And the same volume or amount can be poured and look like it's in different shapes. So if you look here at the two glasses, this is the same amount of liquid, but because this is a tall, skinny glass, it looks like it has more. This is a shorter, wider glass, so it looks like it has less. In actuality, they have the same amount in them. The only difference is the shape of their container. So the molecules in a liquid have more energy than solids and less than gases. Liquids are kind of like the middle child. They always have more than a solid, but less than a gas. They have enough energy to overcome some of the attraction between their molecules, so they can slide past each other. And you remember in the last slide, all of these are really tightly packed together, and now we can see some space, and they just slide past each other as they move. The last state of matter is gases. Gases do not have a fixed shape or a fixed volume, meaning they could be any shape and fill any space, and they have the lowest density of the three states of matter. So here we have a liquid. This liquid, and you can see the little arrows here of the little piston trying to push down, it doesn't move because liquids have a fixed volume. But the gas, they could be compressed down. So depending on how much pressure or temperature or the shape of the container determines the shape and volume of gases. Gases have the highest molecular energy, their particles have enough energy to move fast enough to overcome almost all of the attractions or bonds between them, so they pretty much move independently. They kind of run around in their containers like wild, crazy people, running in straight lines, bouncing off of each other or the walls of the container. That is the end of the video notes. So please return to the class website, watch the DE video listed on the website for today's lesson, and then complete your states of matter output.